Welcome to the Endo meeting on April 8th, 2026. We have guests from Flashbots today. We're going to talk a bit about Endo, SES, AI, Flashbots, the works. Let me introduce Tina. Tina.
Great. Um, I'm a co-founder and steward at Flashbots. Within Flashbots, the team that we focus on a lot of the intersection with potentially Endo's work. Our interest in exploring OCAP is primarily in Flashbots X, which is this special unit within Flashbots that's experimental. Folks that you see here invited on the call are primarily from Flashbots X with Andrew Miller, who I don't know if he gets joined the call, and Dan Matthews. And I also invited our product steward at Flashbots, Dan Marzek, DMars, to dial in as he has been a big fan of the OCAP line of work. So I'll pause here.
Yeah, and let me introduce some of the folks on the call. We have folks in the Endo community coming from Agoric, MetaMask, and let me know if I missed anything. I think that, yeah, we're mostly Agoric and MetaMask folks today. Um, and Mark, Andrew, I believe that you've met.
Yes, we know each other. Andrew, I'm a very big fan and very excited to see that you are involved in this.
Yeah, likewise. It's great to see you again, Mark. I think we met in person just once, and I think it was like 8 years ago or so now, but yeah, absolutely.
Okay, great.
Yeah,
Um,
how would we like to center the conversation?
one this is probably not the most important thing to talk about, certainly important, is um, how has your experience of using SES been? How confident are you that it's providing the security that you need? And what improvements um, uh, would you like to see happen?
Andrew, you're muted if you're speaking.
Yeah, give me let's see if maybe able to show something that makes this clear. I don't know what the state my demo was in, but I mean, I've only used SES very recently, and in this one context, that's probably a little confusing to explain, but I should probably just try to do so. It's the latest demo in a line of demos called OAuth 3, which is like the unlicensed name because it just says OAuth 3 does not exist if you search for OAuth 3. So this is like an unofficial, unofficial name for experimental delegation. There's a couple of other projects that also use the same name. So, this is one of them. And what I use this for, I'll just go to the concrete example. So I use this to do delegated YouTube watch history. So I have my kind of sensitive personal data set, my YouTube watch history. And then I use this OAuth 3 demo to allow scoped access to like enumerate just the titles of the videos or category of the videos, something customizable like that. And so there's two places at which there's like LLM drafted code that runs with these. So first of all, I define those limited scopes by writing SES code. I use a coding agent to do it, but I still like review it and upload it, and that's how I am creating my LLM assisted scope. And then I specifically use the SES endowments because the, avant-garde way that I do this is I put the YouTube history, the credential to fetch my YouTube history in this SES container. And then these scopes are presented as functions that are available to an untrusted sandbox that if I give people this URL link, it's like a permit that lets them upload SES code. So it runs on my TEE server having SES endowment gated access to the underlying YouTube credential. So it does involve, the real deal of OCAP in the sense that I am running untrusted JavaScript code that I don't control where it came from. It runs in a sandbox where, SES is the thing that's keeping it isolated from anything else. Except for SES, there are real powerful credentials on it next to it. And the endowment mechanism was a nice, effective way to, let that sandbox code have limited capabilities, no network access, no disk access, only the little function handles that I gave it. And those function handles encapsulate control over the Power YouTube web login. Um, I can't say I love the question of like, how confident am I that it's working? I didn't spend too much time on this demo. It was a quick vibe code draft. I had meant to check in on SES, more frequently over the past couple of years. So this was all, in a hurry, in a blur. I'm not even sure what all the code does. Um, the documentation I found pretty easy to follow. That note, getting to give the endowments right there. I thought for a while I went through trying to do this with Dino first, then Endo, and then realized that even with Endo without the SES version, I wouldn't be able to give these endowment functions. Um, Probably for everyone, it's probably going to be useful to go dig into like exactly how that works. And so, I guess my answer is at the architectural and design level, it provided everything that I was hoping it would. Um, and I think that's it. I don't know when I will. I guess I'd have to go look further with like an auditor eye to see if I, spot any reasons to be concerned that it's not, isolating what I'd expect. Oh, I mean, I know to look for things like side channels in this environment or timing side channels. So that could be, an avenue that I would want to poke at for the boundary of isolation being, what I expect versus what I get. Um, Okay, I feel like that was all a mouthful, but happy to, dig into that. I think I've shared the link to the code that I'm referring to with all this. I'll go paste
Yeah.
it in this link.
Yeah, I think that there's stuff to dig into there. Because you have a credential in the same process, we do have to think about what timing channels were introduced so that arbitrary code, um, which may be doing a timing attack, might be able to read it out. The but that's, I think, again, trivial to mitigate by simply keeping the credential in another process and using a CAPTP, a capability transfer protocol, to provide an additional level of isolation. The or simply make sure that you haven't got any timing. We don't introduce timers by default in SES for this reason. So
Yeah, we've yeah, by default, a newly constructed code running in a newly constructed compartment is denied the ability to measure duration. But as it interacts with things outside the compartment, if it's interacting with something that's measuring duration, it's very easy for that code to accidentally leak the ability to measure duration. Um, but yeah, we make those are that's the extent of SES's claim to prevent side channels is to for code that can be denied the ability to measure duration to prevent it from reading a side channel. And of course, there's no suppression of the ability to write a side channel that can be read by other things that can measure duration.
well, I think that's a good foundation for a conversation. I think that Tina has suggested that you're looking to do, like, to build on this foundation, possibly doing more with OCAPs, possibly more with pet name systems. Tina, do you want to talk about that?
So basically, I think that each of us here may have a slightly different areas of interest with OCAP and what exactly could be built upon the existing line of work. Um, so I can only speak for from my perspective. So on the one hand, the Olaf 3 line of work that Andrew has somewhat had demoed, and is a line of work that we put in a lot of thoughts last year, inspired by a lot of the Mark and the Agorix team's work, of course. And the primary purpose is actually much more so servicing, um, like I think some of the real world, I guess, or agentic application, agentic interaction, um, from uh, uh, like basically the security and capability trade-off. But here we may be using security and capability much more loosely than what Agoric's definition is about. And so there are concrete application directions that we're interested in exploring. A lot of the experiments that Andrew is building on the application side through this project that we are accelerating within Flashbots X called Teleport Computer. Andrew can share a bit more on how he envisions, like, growing or utilizing or all three in a more in the agentic application context. And separately, Dan Marzek from the more Flashbots block building line of work has actually came across OCAP from a completely different angle. I'll let him speak to it so that you can see the drastic difference in use cases and how we're our understanding. But I would say that overall, like especially myself, uh, is I would say a student here to learn and to understand and to help facilitate. So yeah, so maybe I'll ask D Mars to go first, as he was the first person actually before Andrew mentioned it to bring it OCAP to my understanding, and then I learned a lot more from Andrew in discussion with the whole cohort, and of course Dan Matthews here as well, who was deeply involved in OLA 3 line of work last year. So Dan, sorry, D Mars, do you want to go ahead?
Yeah, cool. I can give a little blurb. Yeah, so yeah, it won't be the most succinct thing, so but I'll try to keep it a bit short. Yeah, so one of my intros to OCAP was actually a project called Wetware. I think they had done some. It was a friend of mine who works on that project and had done some contributions to Captain Proto. So I've been aware for quite some time, and I'm always randomly, within Flashbots, seeing a little spark of where it could be useful. And yeah, without like a proper example to go through, I think the best way to sort of explain it is we've got a lot of private data and capabilities across a disparate array of TE machines in our Ethereum block building network. And it's just sort of the second you try to like stack two of those together, I think you start to see how you could abuse capabilities between different machines. These usually have the flavor of, okay, I'm a user with some sensitive financial data, and I want to have some, arbitrager use my information to find a better arbitrage, and then those results being somehow like accidentally passed, or that capability being accidentally passed to someone with more malicious intent. But yeah, that's the TLDR. Happy to. I can provide some maybe better examples async in a document if that's helpful or anything like that.
I think it's a good example. Um, yeah, essentially, an oracle is a capability that you wish to hand off to an arbitrager that is operating on your behalf and not want it to leak to, or not wanting it to accidentally be delegated to an arbitrager that is working against you. It's a or racing against you. I think that's a really good example, especially because data is slippery. Timely data is um, that OCAPs are more useful in guarding timely data than they are at guarding data in general. Basically, if you give a right to read something, once it's been read, it's out. The OCAPs can't prevent you from reading it again later. But timely data is that's more OCAP-y, I think. Wish we had Dan Finley here. Dan Finley's done some work on OCAP-like delegation on Ethereum in particular. I'll see if I can get him out of band. Um, Dan Matthews, do you want to speak to your perspective?
Sure. So, it's been, I think, since almost a year since we've been actively talking about this, and it just sort of resurfaced. So I'm going off of relatively old memory, but I think one of the really important points that we were driving at when we were last investigating this OAuth 3 and where OCAP would live is this idea of trying to use the user's activity to derive their security preference and abstract away the necessity to for the user to have to grok complicated screens of authorization permissions. Certainly with the ability to override, but the conversation was really centered heavily around how agentic actors could kind of abstract away that necessity from the user and secure their accounts in a way that matches what they would want, similar to how we all sort of, and the people in our lives, we can kind of guess at what they would and wouldn't be okay with. So I think that's the addition to the other things that have been said that I can provide from my memory.
Permission management is an interesting angle. Um, yeah, I think that even with OCAPs, there are a lot of unsolved problems in that space. But Mark Miller and Mark Stiegler worked a lot on OCAP-like user interface stuff. Mark, do you want to talk about speak to the point?
Yeah, so restate the
Yeah, like one of the things that Dan has spoken to, a point that Dan has spoken to is looking to OCAPs as a way to solve the problem of large amounts of inscrutable knobs for permission management from a user interface point of view.
Okay. So yeah, the basic. Actually, let me just do this historically. At my mentor on capabilities is Norm Hardy, the creator of the Kikos operating system. Um, uh, the At one point, Norm made the inscrutable Zen-like pronouncement that the clipboard is inherently hostile to capabilities. Drag and drop is inherently friendly to capabilities. And this, and then probably independently of that, Mark Stiegler came up with the key insights of CapDesk and the DARPA browser, which was our first real example of a bringing capability security properties out through the user interface. Ka-Ping Yi wrote the seminal paper on the 10 elements of secure usability that for which it turned out that Capdesk did 8 of the 10. And then Mark Stiegler, Alan Karp, and Tyler Close were involved in a series of working systems done at HP Labs. The main one of which is and research papers to go along with it, primarily HP Labs tech reports about further secured user interfaces along these lines, all starting with the desktop graphical user interface paradigm. And the key idea goes back to another one of Norm's classic Zen koans about security, which is a capability bundles designation with authority. So the idea is that starting with at the programming level, when objects talk to objects, they pass pointers to yet other objects all the time. It's a central part of what it means in any programming language, pretty much. If it's not objects, it's closures or something similar. And these are acts of designation. They're object Alice explaining to object Bob that Alice wants Bob to do something with respect to object Carol, which Alice already knew about and is directing Bob's attention to. So that's designation. And Norm's observation is that we can just have this designation passing also be the means by which permissions are delegated. So in the same act of Alice telling Bob about Carol by passing it a pointer, by making the pointer into a capability, which is already sort of implicitly what happens in any memory-safe language, Bob acquires the permission to talk to Carol. So now, bringing it out to the user interface, the act of drag and drop is the user, as Alice, telling the drop target about the drop source. So the drag and drop action is already an act of designation in a graphical user interface. And you're telling the drop target about the drop source. So in Capdesk and the DARPA browser, we overloaded drag and drop to also be the means by which capabilities are conveyed. Now, we also actually did create a secure form of copy paste and cut copy paste clipboard, which was definitely a pain for all the reasons that Norm brought attention to. But the basic reason why the clipboard is a pain is because it's basically a single shared global variable that in the normal architecture that anyone can read and anyone can write to. So once you've written to it, anyone that can read the clipboard can see what was written.
Right, which we begin to see as a pattern on operating systems like iOS, that they're beginning to ask before allowing an application to read.
Mm-hmm. So the other main example, in fact, the central example that was came from Mark Stiegler's work on Capdesk and the DARPA browser is the open file dialog box, which is normally when you, on a text editor, let's say, you hit the open button on the text editor, and you get a file dialog box to select which file you want it to open. It's the text editor itself that renders the open file dialog box so that it finds out what file you want it to open, but that means that it already has the ability to edit any file of yours. In Capdesk, CapEdit was our demonstration editor. It starts off with no access to your file system, no ability to even see the namespace. But when you click on the open button, it has the ability to ask Capdesk to ask the user what file to edit. CapDesk then renders the open file dialog box, and the user selecting a file then conveys to CapEdit the capability to edit exactly that one file. And the result is that the user experience is essentially what they're currently used to, simply having made the active designation that was already there in our user interface become the act of conveying permission. So now fast forward to the present, where chat has made an amazing comeback as a user interface style, largely due to LLMs, but also due to the use of things like Slack and such being such a dominant part of human-to-human interaction. And all of these systems have some kind of card, like the at username embedded in the text, which are specially recognized when they're typed and specially rendered when they're read, to distinguish them from just the normal prose text. So now Chris has been using exactly that familiar card act of designation, which has mostly been used for humans designating other humans to yet other humans. The human Alice talking to human Bob, designating human Carol. But Chris has been overloading that active designation as distinguished in modern chat user interfaces to also be the act of permitting, and where any of the players might be human or might be code, and including might be confined code. So I think that brings us up to current the where the namespace itself is the pet names that were a fundamental aspect going back to CapDesk and the DARPA browser of how to create in order to bring capabilities out to a human user. Human users are incapable of memorizing large numbers of cryptographic keys. So you need to give the human some kind of namespace for designation that has as much of the capability security properties as it's possible to enable a human to intuitively deal with.
Yeah, that catches us up, I think. The right, yeah, ending with designating a reference in a message in chat being yet another idiom, user interface idiom that is friendly to OCAPs. Uh, However, there are main problems for naming fatigue. The challenge there becomes another layer of challenge where you're obligating a user to provide names for all of the things that they wish to refer to in the future, and that can become a burden as objects, as capabilities start to vie for more desirable territory in the namespace. Hierarchy helps, enabling the user to have a naming hierarchy, and to that end, our pet namespace is kind of like a file system for capabilities. That is to say that it's like a it's like a file browser, except that you can that the files themselves can designate capabilities, not just static files or
And also it's not a hierarchy; it's a naming graph. It's a naming graph with labeled edges, and all of this, the pet names and lambda names, you familiar from programming, are very, very close. And the naming graph is also very close to normal programming practice. So it's, I think, worth making that analogy. In a conventional programming language, when you say the expression foo.bar.baz, The foo is the name of a lexical variable that you look up to get a value. And then if the value is, let's say, something record-like, then it might have a property named bar, whose value is another record that has a property named Baz. And then the value of the property named Baz might be any first-class value. So in a the dotted the dotted name path as an expression is starting with the private namespace centered in the utterer, which is the local pet namespace of the user in the analogy, and then that takes you the corresponding scenarios that takes you to a naming hub, which is like a record but potentially mutable. And then the path takes you to whatever that first naming hub's binding for bar is. That takes you to another naming hub that has a binding for Baz, and that's how the same kind of naming path is dereferenced in a pet name system. So the dereferencing is essentially exactly parallel logic to normal programming practice. The reason why it's a pet name and not just a lambda name is in order to take a first class value and render it back to a user in a way the user can understand. You want to map it backward from the value to some name that the user already understands, if possible. And the analogy there is when you receive a phone call on your modern, on your modern cell phone, and the caller is someone that's already in your address book, you see your pet name for them. There's this backward mapping from phone number, which is like pointer or global pointer or address that's not human meaningful, but is global, like key material is. Mapping that backward to your own private name for that value.
Dan, did that go where you thought it might go?
I I think I need to digest it more.
Yeah.
It was very you filled in a few gaps for me, and I appreciate that greatly. I I guess I wonder and was wondering when we were last talking about this, how uh, I get caught in the world of how many variable security permissions there are, right? When you take all of the applications, all of the social networks, all of the sources of data that we have, and then mapping the human language understanding back to the permission in a way that's consistent and free of hallucination is where I start to go in terms of my thinking. And sorry, I'm being a little incoherent about this as well. I'm this is not where my brain was at 20 minutes ago.
For sure. For sure.
So yeah, yeah, that was very helpful. Definitely a lot of food for thought.
Yeah,
I,
and with regard to the issue about how realistic this is, let me emphasize at the outset that we have a lot of sort of abstract thinking about why this is theoretically something that a human could use securely. We've got some empirical evidence in the small that it's true, but we've got no real, we've got no like, um, uh, randomized control trials or anything, even in the small, and we really have no data in the large. Um, and there's lots of reasons, I think, along the lines of what you were just saying, to be skeptical that humans can actually successfully use this to stay secure in the large. But the one claim I will make is I haven't seen anything better. So it's a problem that needs to be solved, and I don't know of any better starting point. But I think there's a lot of work needed, and it might be that under empirical testing, we see that we really just haven't even gotten anywhere yet, that this is just not realistic in the large.
Can I ask a question that could perhaps bridge, and I also would love to learn the MetaMask example. Um, yeah, well, so basically, so there's a couple concepts I'm wrapping my mind around. One is I find it very fascinating with the approach with a familiar, um, how you intend to use actually AI to help, I think, navigate some of the, I would say, UX hurdles, I think, in a very elegant way. Um, like again, like how we instantiate um, uh, uh, what our intent and translating it into um, like capabilities, and how do we eval that? That's one of the loops, I'm trying to understand. Um, like from there's I think the eval from within the system perspective. There's also the uh, a broader eval, looser eval from how do we the feedback loop, which I think we alluded to, but I'm just trying to. There's also the LLM eval, which is a different thing. So I want to be, caveat that there's using this term is very it's not precise enough. But in general, like again, how do we know the translation, given that the fuzziness of human expression, limitation of semantics, that's one question. The other question is that one thing that when we delved into what we memed as OLAW 3, as Andrew explained last year, that one concept that's very fascinating that has to do with change management when it comes to permissions is this is GNAP, this negotiation process. Um, and so like I'm trying to understand whether within OCAP, within Endo, familiar, like how like it is a bit nuanced when it comes to these kind of feedback loop and also updating that's based on negotiation based. I can expand. I'll pause here.
No, I get it. I get the question. There's this tension between um in order yeah, there's the loop is a human expresses their intent. An AI agent expresses an enforcement mechanism. That enforcement mechanism may be hallucinated and is likely to have problems of multiple kinds, not just whether it actually satisfies the intention of the user. And so there's like one edge is propose in human language what you want. The next edge is AI agent proposes code that would deterministically enforce the policy, and the missing edge is review. And if we're trying to enable non-programmers to reason about the policies that they're trying to create in order to protect their interests, that third edge needs to get filled in a meaningful way. And currently, the only meaningful way we have is enabling them to be at least casually versed in the ability to read a program and understand what it does. You don't have to be a programmer anymore. You don't have to be able to write programs, but you do need to be able to read them in order to understand what they do. And I think that that's a gap that we might be able to fill with better symbolic representation of intent from a deterministic program. And there are ways to do that. There's like graphical representations of code we can use. And I think that there are like simplified programming languages that we might be able to use in order to create simplified visualizations of intent, especially for a DSL that's designed for attenuation of an object capability. But that is science fiction. Let me show you what isn't science fiction briefly before I hand this over to Kamavis to talk about the delegation framework. This is the prototype of the familiar in its current state. I I ran a demo and it's in the end of demo state, so I can very quickly, without having to wait for the AI agent to follow up. But I'll just walk through what we did for the purposes of a demo. We start with a plugin is in the space that allows you to spawn AI agents based off of your credentials for whatever inference engine that you're using, and then to give them a name in your pet name space. In this case, we have created an agent called lol with whom you can chat. Lol immediately goes and looks at the only thing that lol has in the initial case is this primer, which is a tree that contains documentation essentially about how it's able to that instructs it in how to use its capabilities, how to use capabilities in general, how to use the tools it has, how to help the user using them. Um, and it goes and reads the README and proposes, hey, here are some things that I can do for you. The agent runner reports that they spawn the agent, which you already know. Then you can do basic inference test. This is just, can the inference engine accurately answer a question about how many R's are in strawberry? But this is the realm of hallucination. It would be better to say, can you propose a program that does the same so that you can review it and then endow it with a capability so that it can produce a deterministic answer. So the human is in the loop at this point and needs to be able to understand a small program in composition with the capabilities they wish to give it. And this is a trivial example where the endowment is data, but I created using the command line a strawberry capability, which is just a capability, a reference to a string, and then ran that. The important thing here is that I was able to ask the agent to propose code without endowing the agent itself with a capability. The agent does not get anything that I send here. This is just running a program. And then this, yeah, so it reports what it did because this isn't just the agent. The agent can communicate with multiple parties. You can introduce it to another party and they can chat with them too. And then you can have a multi-party conversation where the agent remembers and retains capabilities that were provided by multiple third parties. Yeah, so then I can do things like this, like endow. I can send a message that contains a capability as an endowment embedded in the message itself, and it's able to go off and use its tools to inspect it. And then I gave it a capability to write into a scratch space on my file system, and it did so. It created this README for an open source library of which it only knew that its name was Trout, the inference engine, of course. It doesn't reliably do this, but I am always amused that it assumes that it can infer that a library named Trout is for streaming. And then
I would assume that any library named Trout is open to a phishing attack.
right, clearly. Yeah, so then I've been doing a more complicated thing. This is getting more into what attenuation looks like. I asked to propose a program that attenuates a file system to be a read-only file system, and it wrote up some code that again is a wall of text. It's not that much because we're doing these things in isolation. You give a capability, produce a capability. It's not a whole application that you have to understand. This is actually relatively straightforward to review, but probably a lot easier for a programmer than a non-programmer. The which is the gap in that third edge of the feedback loop. In any case, it did a pretty good job. It created a read-only impression, and then I was able to confidently pass that read to create. I was able to submit my readable writable file system and produce a read-only version of it, the read-only Lalder, gave it its own source code, and asked it to summarize it with that read-only capability, which it then did. And that was the demo. Um, the the which is to say, I think that I'm answering the question: are there any good examples of an AI agent using OCAPs for delegation? This is
Ask a few
the
examples and go over, or a few questions and go over that example somewhere.
sure.
A
I'm
couple of
sorry.
things stick out. So one was that it seems like you made a deal about the agent not having tools, like it isn't executing the code, it's just writing the code. You did say it has access to a Scratch file, and I was kind of imagining that like it would you'd encourage the agent to have access to a sandbox execution, so it can like test or debug, because if the sandbox is secure, then it's not inherently harmful to have the agent running code, and actually probably helpful for it to be doing it because it's running tests and debugging that way.
Yeah, my what I tried to do in this demo was to show you two modes of usage. One of which was the where the agent was unendowed, and then another example where it's endowed with a limited capability, and then using code using the agent to create an attenuation, and then giving the attenuated capability to the agent. All of these kinds of orchestration are possible, including the one you describe. And what, like for example, in the case for the Scratch file system, it did receive the capability to read and write in that space, which I think is the sandbox that you're speaking of. We haven't gotten to the point where we have all of the tools in place for like doing shell script level sandboxing, but it's around the corner. Josh on the call has been working on that. Um, it's possible. It's possible to do safely.
I had two more questions on the demo. The first one was about, well, I guess conceptually how this compares to other modes of delegation in agents or coding agents. So, like in Claude Code, there's the gradual permissions thing. Like it starts off with nothing. When it wants to run Python script, you have to approve the Python script. Eventually, it'll ask to approve, Python star or some, class of things. And so a common pattern is maybe across sessions. Like in one session, you create a Python file. That Python file may call some other ones. And then in a later session, you have a new agent. So by default, it doesn't have anything, but now you give it access to just that one new file. So that basically is an attenuation pattern, maybe that you might even argue could occur, in practice, or be some recommend that someone even outside of a specific thing, just so you can do that style, even in existing agents like Quad Code. Um, yeah, any reaction to that, or is there like a specific point of difference or other?
There the one of the things that we can do that system doesn't do as easily is revocation. You can reach into the namespace of all of the capabilities that the agent has access to and simply delete them. Um, and there uh, and then there are also like it would be useful to compare and contrast how much expressivity you get relative to the amount of interactive permission management you get. Um, the agents, yeah, the within Claude, yeah, a lot of these things, a lot of the same patterns are possible. I think that our system is more extensible because the with Claude, you're able to do file system and exec attenuation, right? And with this system, we can do more elaborate kinds of attenuation using JavaScript as a plugin system. The like, for example, it becomes relatively straightforward to express an attenuation like, I would like this agent to be able to book me for meetings in my calendar in these date ranges, for example. Um, that's the kind of capability expressivity that we want to encourage.
The last question I had on it is like, can you what's the notion of like remote execution? So like, can I make a capability on one? I typically run an agent on my laptop, but also on some remote server, and then it's a hassle to port things back and forth. Lots of just copy pasting of API keys. I think it would be really cool to, for example, to be able to define an attenuated ability to run commands on my laptop, for example, and then expose that through WebRTC or some webhook thing if the routing works right. Essentially
Yes,
offer a limited RPC on my laptop to an agent that's running remotely somewhere.
that almost works. We have a capability transfer protocol that and the system is designed to allow a familiar application that is running with a personal daemon on your laptop to also connect to a personal daemon that is running on another system. And there's a command in the interface for entering a profile, and that profile can be remote. So you can stand at a single user interface and orchestrate agents on multiple other machines.
Point of order. It is almost the end of the hour, and I feel like we've, maybe gotten through a half of what we should be talking about. Um, can all of us stay late? I can stay late.
I can too. Yeah, all right. With that, Andrew, do you have further questions?
Oh no, I'm good. At least for a
All
while.
right. All right, then let's hand this over to Kamavis. Kamavis, would you like to speak a bit about Dan Finley's delegator framework?
Yes, let me choose the screen I want to share here. Is it working?
I
Maybe.
see.
Okay. So,
Yep.
despite the pretty rainbows, this section specifically on the delegation framework was the most rushed part of this already rushed talk or slide preparation. But I think I can convey it, especially if you already have familiarity with Ethereum. So we're looking at how did object capabilities affect the development of smart contracts using MetaMask's delegator framework. And so the first thing that you may understand already is that smart contract code is primarily off in terms of lines of code or something, and that's all like custom authentication code, and that's where we find the bugs. And so by the introduction of MetaMask delegation framework, which basically is it's a library for creating a smart account, and it's also a library for making contracts. So that way you can introduce delegations either on the account side or on the contract side. And so it's basically if there's anything you can do on chain, you can let someone else do that on your behalf or do some limited version of that. And so the that limitation or that attenuation is called caveats in the delegation framework. And these are messages that are signed off chain, and then they are submitted in a transaction and enforced on chain. And they're composable. If someone delegates something to you, you can then delegate it on to someone else. You can add another attenuation and sort of thing. And so how this changes smart contract development is here we have like some NFT contract. This is all just an example. But it has all this custom logic for how you want to be able to do the core thing, which is just like have ownership and transfer ownership. And that can all disappear from the contract implementation. And then you just basically have your core functionality. And then the ability to allow someone else to do that on your behalf or do it when some condition is met, like an exchange of an asset or something like this, all just comes out of a single implementation in the delegation framework. And then yeah, I guess so you are making if you may be making as a user or as a dApp some user specific attenuation of this. And bugs can lie in that. So it gets pushed out to the outside, but it's not stuck in a hard to upgrade contract. It is revocable. And so all the as a smart contract developer and as a smart contract developer, you only have to implement your core functionality. As a security reviewer, you only have to review that core functionality, and all the authentication, delegation, caveat development, it happens outside of the core contract. And so in a few reviewed examples, we found a 95% reduction in smart contract code. So we found that pushing the custom auth out of the contract was very, very helpful. I did not work on this project, so I'm doing my best to represent it accurately. But Dan Finley is a good person to ask further questions about.
Yeah. We're just a couple of minutes over at that. Are there any further questions about that, or would perhaps we can continue the conversation in another meeting in the future?
I would love to see a Flashbots demo, and especially with making explicit the connections to what we're discussing here.
An existing demo or a future demo?
I mean, if you guys have something that you can demo right now that would help us understand what you're doing and how it relates to SES and OCAPs, that would just be awesome because I really don't know what you're doing.
Andrew, perhaps I feel like Andrew was doing gave one example at the beginning, but there were quite a few additional ones we can kind of find or explain, I guess.
You don't want to demo the RL gem.
I don't think it's at a stage where there's OCAP is incorporated yet.
As long, I mean, you can talk through the stuff I mean, as long as it's helping to bring us up to speed on what you're doing and how it relates to how it is expected to relate to OCAPs.
Yeah, maybe instead of a demo, just a few words about what you're building and how OCAPs might come to bear.
Andrew, you go first. You have the most vibrant examples.
What do I want to add next that wasn't just covered? I mean, the where can I branch off from the OAuth 3 demo? Yeah, give me some reaction actually. What do you think about this like notion of delegation this way? I mean, I feel like I'm missing. I feel like there's some kind of key thing that I haven't described that's kind of makes this all make sense in some ways. So I mean, one is that there's this. Maybe this is what I want to kind of explain about it. The thing that's interesting about this approach to delegation is that it is basically doing something that is like the counter wisdom everyone says don't do. It involves taking basically very powerful credentials like a logged in website credential, like a cookie to a website. Even more specifically on our consumer app Feedling that uses TikTok watch history, it's basically the thing that you delegate at the underlying level is this logged in web browser session. So what we do is run a browser remotely on a confidential compute VM. That browser gets logged into the user's account. So that's over delegation. You can, do much more than just look at watch history. You can read DMs and everything else. But because we do it with this open source program and it's running in the confidential compute environment, we can show that actually all that we run is the attenuated version of that because we package up the browser with the script that reads the watch history out of the browser. And that's the only thing that's output. And so this whole thing runs inside of a confidential compute. So that's how we can prove that the only thing that comes out of it is watch history, even though the thing that makes remote watch history possible is just like over delegation there. So this is kind of a trick that only makes sense in the language of attenuation. This on its own does not have a quality of untrusted code running. Like it's just our program that runs, we make it open source. So it does use the whole remote attestation and confidential compute workflow. So it's really, yes, I mean, so that on its own doesn't explain what the connection with the programmable delegation is, although it is like, a trick that you only appreciate is thinking about attenuation and delegation in those lenses. What we want to be able to do for that then later is to be able to do more varied kinds of this. So like we do one thing with watch history, which is send you a weekly email summarizing your watch history, like reflecting your doom scroll habits back to you. But in principle, this should be open-ended for composition, merging your watch history with other people's watch history, for example, to make like a community observatory about trends on TikTok, that as an example. So that sort of open-ended composition, like, oh, it's your watch history, you should be able to aggregate it with other people's watch history for some purposes, that you want for that to be user programmable or support a long tail of kind of interactions would certainly want to be able to do, customized attenuation in that regard. Yeah, maybe that's my best explanation.
No, that's very good. Um, yeah, it comes back to that triangle of the feedback loop of like, how do you trust an attenuation? In this particular example, you have a trusted attenuation because of the open source project, which is reviewable, auditable. Somebody can attest to its, a competent programmer can attest to its, um, the integrity of your claims about it. And we see this as integral to the familiar project as well, because not everybody can be a programmer to review their own attenuations, and being able to share software and then attest that software based off of its integrity hash does what it purports to do and is trustworthy and all of that. And then socially arrive at consensus of trustworthiness of an artifact, and then thereby you get a program and you run it in an execution environment that you trust. You're personally accepting a certain level of risk based off of social information. As Brian Warner is one of the co-founders at Agoric, is also very interested in this particular angle of Brian worked on the personas team at Firefox and Mozilla for a time, and has since then been thinking about, well, how do you build a plugin system where you trust your plugins, and like what degree do you need to trust them? Can they be sandboxed in a way that it minimizes the need to trust them, et cetera, et cetera? Object capabilities fit in that picture. But also this social audit of attenuation.
Yeah, let me just inject I mean, this is what we're doing and where we're going, the social audit. But let me explain where that can be strong and where that can be weak. Um, Copying, the same person I referred to earlier that wrote the 10 elements of secure usability, he also did um, a dissertation, PhD dissertation, on an exercise of creating a reviewably secure voting machine software. And the way in which he wanted to demonstrate that it was reviewably secure is by bringing in a bunch of top security reviewers, of which I was one of them, to review it, and in order to check the quality of review, he and his thesis advisor, David Wagner, injected three security flaws in it. Because I'm sorry, so what was interestingly different about the threat model than the normal security review is it was assumed that the author was the adversary, that the author was potentially malicious, and that the author's intent was to have a security bug in the software that could influence the outcome of an election in a direction that the author would prefer. And that the goal of the security reviewers was to satisfy themselves that there was no such malicious bug in the software. And the way this differs from the normal security review is we normally assume that the author is fallible but not malicious, and that the security threat is that the author might be writing code that's maliciously exploitable through a mistake, an innocent mistake made by the author. And I would say that the history of experience of careful review of code under the fallible author assumption is positive, that we've certainly many flaws slip through, but altogether it's doing, I would say, an impressively good job for small pieces of code with a lot of attention at catching problems from accidental. In this case, the voting machine software was 400 lines of code. It was written in a subset of Python that essentially corresponds to Pascal, no higher order functions, very, very simple and straightforward first order programming patterns. There were three malicious flaws introduced, and Ping ran the exercise twice with 6 crack reviewers each time. I was one of the reviewers on the first iteration of this, and in both cases, it was the case that that no team caught all 3 bugs. That in one that one bug that could throw an election slipped through both teams. What this says is that human review is just not adequate, even for small programs with very expensive reviews. In both cases, the review is about a week. Um, uh, um, the So the human review is just not adequate, even under the best of conditions. And that really for author as adversary, you need to get to formal methods before you can be confident of the lack of malicious flaw in the code. And this again is why one of the reasons why capabilities are so valuable is that independent of the code, you can be confident with capabilities on a bound on what the code might do, even if the code is malicious. So just, sorry, that was longer than I intended, but I wanted to interject that. Oh, and I'm sorry, relating it to the current AIs, right now, we're pretty much all assuming that the threat from the AI written code is accidental, not purposely malicious. But of course, in the
Prompt injection.
yeah, we're all expecting that in the near future, these AIs, given their are still more opaque than transparent with regard to what their intentions are, since they're already mostly opaque, and that they become capable enough to have their own internally generated malice. Now, this is, the malice that might already exist at the current level of complexity is not auto-generated malice, but rather embodying malice implanted by their creator. We really have no assurance against that.
Oh, it's more interesting than that. I mean, what if they made the mistake of reading my blog?
Yeah, yeah, yeah.
That's actually funny enough. The reason why Zaki introduced me to Chris was because I was introducing him to a top rank prompt injector in the LLM world. And we're speaking about running a tournament of red teaming and getting the top jailbreakers to do funky things. And is there a secure enough sandbox question? And that's where I think Agoric's line of work immediately came into sight. And yeah, I do think that is a huge rabbit hole. That it seems quite difficult. Like I think that even Mark's example, if we rerun it today with exactly as Josh suggested in the side chat, would be a very interesting thought experiment or a live experiment already.
Right. A team of mythos
Yeah.
trying to attack our sandbox or some sandbox. All right, folks. This has been a great conversation. We know where to find each other. It'd be great to have a follow-on, perhaps when you're farther along, or if you have more questions. Um, you'd be welcome in the Endoers or AI Endoers signal rooms if you're looking for a venue to join the conversation with the familiar development. Otherwise, um, see you next time.
Thank you, Chris and Mark and everyone here. Great to meet you.
Hi, everyone.
Thank you all.